Hi, welcome to Module 6, kind of moving up the OSI model. Now we're going to be at the data link layer. That's the second layer of the OSI model. And this module is different, only from the standpoint there aren't a lot of labs to this one, but it's helping you understand a little bit about what the data link layer does, because it's kind of the interface between, well, I shouldn't say kind of, it is the interface between the addressing, the logical addressing layer in the IP layer and the physical layer. And it's the one that's got to say, oh, what do I want to tell the physical layer? What does it have to process the bits in? Electrical, wireless, light. So it's got a lot of conversion, or at least information that's got to pass between the data and converting it into something that can be placed on that physical media. So in this layer, there are three major sections. So I'll make, of course, probably three videos here. One is the purpose of the data link layer. Two is the different types of topologies, characteristics of the different methods on a wide area network and a lower local area network, and then description of the data link frame itself. So let's get on to the purpose of the data link layer. What's the purpose of the data link layer? Basically, it is the one that prepares the network data for the physical network. It's responsible for the network interface card and the interface's communications. It enables upper layers of the access of the media. The upper layer protocols basically should be unaware of what type of media that a message is going out on. So it takes data usually from the packet layer, the layer 3, either IPv4 or IPv6, and it encapsulates it into a frame, and that is the PDU of the layer 2 frame. So it's a frame, and it actually is one of those that gives you not only physical addressing on one end, but it also has a CRC or a error correction part at the end to make sure that this packet of information arrive with no errors. So it kind of does a couple of different things. So it's right in the middle here. Well, middle as far as between logical information and actually getting physical information onto the network. Now, what it does is it takes your layer 3 packet, the source and IP address, and what it puts on it is, it says destination network interface card and source destination interface card. But in most computers, it is a MAC address. I'm putting a destination MAC address because every network interface card has that physical burnt-in address that's put in by the manufacturer. When we get down to breaking down the MAC address, half of it is who made that network interface, and the second half is an identifier. Maybe it's a sequence number, whatever that manufacturer wants to use to make sure that it knows which piece it was. So it gives the basic between the physical address and the logical address. Now, the data link layer is actually broken down into two sub layers, only because it's passing two different layers. It's kind of like transition. It's a great transition from a logical piece to a physical piece. So there are a lot of different standards to say, how do I interface between kind of like theory and reality, but you kind of get the idea. It's a major transition point. So you have the LLC, the logical link control piece, and of course there's an IEEE standard that controls that. The 802.2 standard communicates with networking software, the upper layers, and the device hardware at the lower layers. And it kind of puts information in the frame that identifies which network layer protocol is being used. Otherwise, it's telling you, is the network layer using IPv4 or is it using IPv6? And then you get to the MAC address layer, that next sublayer, that way it splits. And this sublayer implements several different types. And it really depends on the hardware that's plugged into it. Is it 802.3 with Ethernet? Is it 802.11? Is it wireless? 802.15? Is it light? Different personal network information. So it just depends on what is going to be attached to it. So you get a rough idea as to what each of the different areas cover. So you got 802.3 is the Ethernet standards, all the way from fast Ethernet, gigabit Ethernet, and beyond. 802.11 is all the wireless standards, and there are definitely a bunch of those based on how fast and how much data you want to process. And then you got some various 802.15 is some various personal networks, Bluetooth, RFID, and the like. But it also looks like some of those interfaces cover, because you got to make sure you're communicating with the physical layer. So that's kind of where those two come into play. So the LLC sublayer typically depends between IPv4 and IPv6. The MAC sublayer depends on what hardware is going to be so that it can come through. Now the MAC sublayer also encapsulates the data that's received from the network layer and any information done from the LLC. Now, some of the things that the MAC layer puts on there is I got to know when the frame, which is the PDU of the data link layer, when is it starting? So it gives you some delimiting bits, some startup bits to make sure that everything's in sync. It's got addressing at the front end, so it's got the MAC address, destination source MAC address, and then it's got an error detection part at the tail end to make sure that that address gets completely delivered at the right place, because you're switching different physical media from device to device, and you want to make sure you got the correct message. It also handles access control, so making sure that how is the information passed in a timely fashion so you're not overrunning the next device. Some devices can only receive information like a walkie-talkie, one-way transmission at a time, which is called half duplex, or a full duplex where I can communicate simultaneously between the two devices. So just be aware, you'll hear about half and full duplex a little bit more later. Now access to the media, as a network packet goes between different devices, it's hopping from one device to another, and what it's basically doing, it once a device receives a packet of information, a frame, it first accepts that frame. It says, okay, you sent it to a destination, I got to accept that frame. Then it de-encapsulates, it takes off, it checks the CRC, makes sure it got received the data correctly. It takes off that MAC addressing on the front end, because it says, hey, I've already accepted this frame. Then it looks at the logical, or the IP address scheme, says, hey, do I know anything about this address? Do I have a destination for this? And if not, I'll re-encapsulate the information and forward the frame to the next device in the segment. What I would do is, go through and play this, little video, which goes through a little bit of what that process is. But it pretty much means is when it leaves your PC, it has a MAC address. So what's it do? The source MAC address is of your PC. The destination MAC address is of your router. So the router gets there and says, hey, is that destination address me? If it is, then good, I'll process it. I'll strip off the source and destination MAC address. I'll check that data received was correctly. It says, oh, is it something for me? No. It looks at the IP addressing and says, is it for me? Not. I'm going to move it to the route, to port inside the router to the next device. Change the source MAC address, change the destination MAC address, and send it on its way. So looking at that, you want to look at that process a few times, and we'll go through that. Now, of course, the different standards that are involved, you've got several different groups, IEEE, International Telecommunications Union, ISO, ANSI. All of these have small aspects of how the organizations control different aspects. I'll let you run through the quiz. And then I'll move on to the next video on topology. Have a nice time.